This is the final part, and we're going to look at ways of studying the brain. So you need to be aware of scanning techniques including functional magnetic resonance imaging, fMRI, electroencephalogram, EEGs, and event-related potentials, ERPs, and post-mortem examinations. So I think the best way to revise this is as a table. So I'll go through the table for each of the techniques. So we've got an outline of the technique, strengths and limitations for each of the techniques. So, fMRI is a method used to measure brain activity while a person is performing a task. fMRI detects radio waves from changing magnetic fields. This enables researchers to detect which regions of the brain are rich in oxygen and thus are active. Strengths. It does not rely on the use of radiation and is virtually risk-free, non-invasive, and straightforward to use. It produces images that have very high spatial resolution, providing a clear picture of how brain activity is localized. Limitations of fMRI. It is expensive compared to other neuroimaging techniques. It has poor temporal resolution because there is around a 5-second time lag behind the image on screen and the initial firing of neuronal activity. This means fMRI may not truly represent moment-to-moment brain activity. Next we have EEG. EEG is a record of the tiny electrical impulses produced by the brain's activity via electrodes that are fed to an individual's scalp using a skull cap. By measuring characteristic wave patterns, the EEG can help diagnose certain conditions of the brain. EEG is often used by clinicians as a diagnostic tool to investigate unusual arrhythmic patterns of activity that may indicate neurological abnormalities such as epilepsy, tumours, or some sleep disorders. So when we looked at rhythms, biological rhythms, you'll have looked at the stages of sleep, and the stages of sleep those waves and that diagram are an example of an EEG. Strengths. It is useful in studying the stages of sleep and in the diagnosis of conditions such as epilepsy. Unlike fMRI, EEG technology has extremely high temporal resolution, detecting brain activity at a resolution of a single millisecond and even less in some cases. Limitations. The EEG signal is not useful for pinpointing the exact source of neural activity. It does not allow researchers to distinguish between activities originating in different but adjacent locations. So because it just takes activity from across the whole of the brain, it's really hard for us to locate the specific areas in which the activity is occurring. Next we have ERPs. ERP, the electrophysiological response of the brain to a specific sensory, cognitive, or motor event, can be isolated through statistical analysis of EEG data. So it's similar to an EEG in terms of the setup. However, you're using a specific stimuli in this. Using a statistical averaging technique, all extraneous brain activity from the original EEG recording is filtered out, leaving only those responses that relate to, for example, the presentation of a specific stimulus or performance of a specific task. What remains are event-related potentials. These are types of brainwave that are triggered by particular events. So strengths. They are more specific in measuring neural processes than EEGs. They have excellent temporal resolution compared to neuroimaging techniques such as fMRI. Limitations. There is a lack of standardization in ERP methodology between different research studies, which makes it difficult to confirm findings. In order to establish pure data in ERP studies, background noise and extraneous material must be eliminated. This is a problem because it may not always be easy to achieve. And our final method, we have post-mortem examinations. The brain is analysed after death to determine whether certain observed behaviours during the person's lifetime can be linked to structural abnormalities in the brain. Areas of damage within the brain are examined after death as a means of establishing the likely cause of the affliction the person experienced. This may also involve comparison with a neurotypical brain in order to ascertain the extent of the difference. Strength. Post-mortem evidence was vital in providing a foundation for the early understanding of key processes in the brain. Broca, Vernix both relied on post-mortem studies in establishing links between language, brain and behaviour, decades before neuroimaging ever became a possibility. So before we had fMRIs, EEGs, PET scans, etc., post-mortems were really, really important. Limitations. Causation is an issue within these studies. Observed damage to the brain may not be linked to the deficits under review, but to some other unrelated trauma or decay. So because we're looking at them after death, whatever has caused their death or the period of time between their death and the examination may cause the brain to change, and the areas that we're looking at and the damage that we can see might actually be linked to that process and not to the actual affliction that that individual was suffering from. Post-mortem studies raise ethical issues of consent from the individual before death. Participants may not be able to provide informed consent, for example, in the case of HM, who lost his ability to form memories and was not able to provide such consent. Nevertheless, post-mortem research has been conducted on his brain. So they actually preserved his brain and sliced it so they could see all of the differences within his brain, and they could have a look at all of the different sections, cross sections within his brain, and they linked that damage to his afflictions. Okay, so you have got all 4 different ways of studying the brain, and you need to know the strengths and limitations for each. You also need to be able to compare one with another. So if you have a look at some of the practice questions in the worksheet, there's some comparison questions. So break this down and try to reduce those evaluation points just down to a few key terms for the strengths and limitations, and this will help you remember the differences between them.